Welcome to the video of Techniques of Solution to Equation. In this video, we will discuss about solution of equation using matrices and using determinants. Also, the characteristic equation, eigenvalues, eigenvectors and Cayley-Hamilton theorem is discussed here. At the end of this video, you will be able to explain the solution of equation using matrices, explain the solution of equation using determinants, define characteristic equation, define eigenvalues, find eigenvectors and use Cayley-Hamilton theorem. Now, let us find the solution of system of equation using matrices. Let us suppose that you have a system of equation x plus 2y is equals to 3 and 2x plus y is equals to 4. So, this is the system of equation in two variables and two equations, two unknowns and two equations. So, we can find this by so many methods. Here we are going to introduce the method of matrices to find such type of system of equations by making use of matrices. So, if we are going to write this equation in terms of matrices, it will take the form 1, 2, 2, 1 into your x, y, this is equals to 3, 4. You can see that if you are going to expand it, it will be this form. 1 into x plus 2 into y, this thing is equals to 3. 2 into x plus y, this is equals to 4. So, this is what we get. So, this is your A, we call this to be your x and this is your B. So, this system takes the form Ax is equals to B. So, actually we are interested in finding the values of x and y. Solving system of equations in two unknowns means that we want to find the value of unknowns. So, we want to find the value of this x. So, from this equation, how you are going to find the value of x? If you are going to multiply both sides by A inverse, this takes the form A inverse into Ax, this is equals to A inverse into B. So, you can write this as A inverse into A into x, this is equals to A inverse B. But what is A inverse into A? This is identity matrix. So, I into x, this is equals to A inverse B. Any identity matrix multiplied with any matrices, it is going to be the matrix, same matrix. So, this is x is equals to A inverse B. So, to find the values of x and y, it is enough if we can find A inverse. So, in our previous videos, we already have defined how to find the inverse of any matrices. Since A is a square matrices, so obviously, it is very much clear that we can find the inverse of this matrix. So, let us first find the inverse of A and then we will multiply that with B, we will get the value of x. So, here A is equals to your 1, 2, 2, 1. What is the formula for finding A inverse? This is 1 divided by determinant of A into adjoint of A. So, what is determinant of A? This is a 2 cross 2 matrices. So, this into this minus this into this. So, 1 minus 4, this is equals to minus 3 is the determinantal value of this A. Now, we have to find adjoint of A. How to find the adjoint of A? What we will do? We will find the cofactors for every element, then take a transpose and that will give you the adjoint of A. Cofactor for this is, leave this list, only one is left with the positive sign. For this thing, this column, this row is left, we are left with 2 with the negative sign. For finding this cofactor for this and this is taken out, you are left with 2 with the negative sign because here this is plus, minus, minus, plus. So, cofactor for this is, delete this one. So, this is 1 with the positive sign. Now, take the transpose. So, by taking the transpose, this is 1 minus 2 minus 2, 1. So, what is A inverse? So, A inverse is nothing but minus 3 into 1 minus 2 minus 2, 1, which is equals to minus 3, 6, 6 minus 3. Okay. Now, let us find out the value of this x. Now, we will multiply this A inverse and B and we will get the result. So, let us do it here. So, your x is nothing but it is A inverse into B. So, A inverse just now we calculated it is minus 3, 6, 6 minus 3, and your B is nothing but 3 and 4. So, this is 3, this is 4. Now, let us do the multiplication part. Minus 3 into 3, this is minus 3 into 3 plus 6 into 4. So, minus 3 into 3 plus 6 into 4. 6 into 3 plus minus 3 into 4, minus 3 into 4. So, you will see that this is 2 cross 1 matrix, because this is 2 cross 2, this is 2 cross 1. So, the resultant will be 2 cross 1 matrix. So, what is this? This is minus 9 plus 6 into 4 is 24, 18, and here it is minus. So, minus 3 into 4 is minus 12, minus 12. So, solve it. So, minus 9 plus 24 is 15, and 18 minus 12 is 6. So, we get x is equals to this thing. This means what is your x? X is your x and y. So, implies that x is the value 15 and y has the value 6. So, this is how we can solve the system of equation by making use of matrices. Now, there is one more method to solve the system of equation by making use of determinant. So, suppose you are having a system of equation of 3 variables and 3 equations. Let it be a11x plus a12y plus a13z, 13z. This is equals to some number, say k. This is a21x, a22y plus a23z. This is equals to some number p. a31x plus a32y plus a33z is equals to some number, say q. So, this is the system of equation in 3 variables and 3 unknowns and 3 equations. Now, we want to solve this system of equation by making use of determinant. So, what we will do is, first we will find out del. Del is what? Take the coefficients of all x, y, z and write it in the determinant form. This is a11, a12, a13, a21, a22, a23, a31, a32, a33. So, this is your del, means you have to find the determinant of this matrix. This is obtained from this one. This is a 3 cross 3 matrices, so you can find the determinant. Now, we will define del 1. How we are going to define del 1? Instead of writing this a11, a21 and a31, we are going to replace this column by the elements from here. So, this will become k, p, q. The rest remains same, a12, a22, a23, a13, a23, a33. Now, we defined del 1. Similarly, we will define del 2. In del 2, what we will do? Instead of writing this column, we will write this k, p, q. So, a11, a21, a31 into k, p, q, a13, a23, a33. This is, we define del 2. Now, we will define del 3. So, how we are going to define del 3? Remove this column and put k, p, q in that column. So, it will become a11, a21, a31, a12, a22, a23. This is k, p, q. Now, you can find the determinants for all these things. Now, how we will find the value of x? So, x is nothing but the first, where the first column is replaced by the elements from the left hand side, that will give you the value of x. So, x is nothing but your delta 1 divided by delta. Y is nothing but your, here in the second column we removed the values of y, put the values from the left right hand side. So, this is delta 2 divided by delta, and z is delta 3 divided by delta. So, find out the determinant, put the values there, you will get the unknown values of unknown variable x, y and z. So, this is how we are going to make use of the determinant to solve the system of equations. Now, let us define the concept of characteristic equation, eigenvalues and eigenvectors. Suppose you have a system of equation given as a11, a12, so on, written in the matrices form a1n, a21, a22, so on up to A2n, AM1, AM2, so on up to AMN into your x1, x2, so on up to xm. This is equals to lambda times x1, x2, so on up to xm. You can write this equation as A, making this as A, this capital X, this is equals to lambda times capital X. So now you can write this as Ax minus lambda x, this is equals to O. O means the 0 matrix. So when you will take X matrix outside, this comes out to be A minus lambda into identity matrix into the 0 matrix. So this means that if you are going to expand it, this will take the form. What is your A? A is A11, so on up to A1n, A21, so on up to A2n, AM1, so on up to AMN, minus lambda times 1, so on 0, 0, 1, so on 0, 0, 0, 1, so on up to 0, m times 0, and here it is 1. So this is also m cross n identity matrix. This is equals to your 0 matrix of row m cross 1. Okay, fine. So if you are going to take this expression, it will take the form like A11 minus lambda, and the rest will be A12, so on up to A1n. The next term is A21. The diagonal elements, because the lambdas are on the diagonal in this identity element, so the diagonal, there will be change in the diagonal element. So A22 minus lambda, so on A1, A2n, moving AM1, so on AMN minus lambda into yes, and this is equals to x1 0, 0, so on up to 0. Okay, fine. Now this will actually, this expression, it is giving you this equation. This is called characteristic equation, means that this equation is called the characteristic equation. So the determinant of A minus lambda I is equals to 0 is the characteristic equation, where this lambda is called eigenvalue of that characteristic equation, and this capital X, this is called eigenvector. So if any system of equation is given or any matrix is given, so with that matrix we can always form a characteristic equation, condition that should be square matrix, because then only we can find the determinant of that one. So if and for any square matrix we can find the characteristic equation, corresponding to that characteristic equation we can find the eigenvalues and eigenvectors. Similarly, if you have any system of equation, with that system of equation you can get the characteristic equation and you can solve it by finding the values of eigenvalues and eigenvector. Now let's consider a example when A is equals to 8 minus 4 to 2. So let's first make the characteristic equation, means this thing. So what would be the characteristic equation? This is 8 minus 4 to 2 minus times lambda into, here the identity matrix will be 2 cross 2. So 0, 1. Take the determinant and it should be equals to 0, means a matrix of order 2. So expand this, you got 8 minus lambda and 4 as it is, this is minus 4, then 2, and here it is 2 minus lambda. This is equals to your 0, 0. If you are going to take the solve this determinant, it becomes 8 minus lambda, 2 minus lambda, and this plus 8 is equals to 0. So, now let us solve this one. This is 16 minus 8 lambda minus 2 lambda plus lambda square plus 8 is equals to 0, or lambda square minus 10 lambda plus this is 24 is equals to 0. When you will solve this equation, you will find that lambda is equals to 4 or 6. Okay. So, this value of lambda is nothing but it is called the eigenvalues of this characteristic equation. So, corresponding to these two values of characteristic equation, we will get two eigenvectors. Now, let us find what would be the eigenvector when lambda is equals to 4 and what would be the eigenvector when lambda is equals to 6. So, let us consider when lambda is equals to 4. So, when lambda is equals to 4, you have an equation Ax is equals to lambda x. So, this is your A is 8 minus 4, 2, 2, x is your, suppose x is your xy, or it can be x1, x2, anything whatever you want. Should we have taken any notation for that one? No. So, let it be xy. This is equals to lambda is 4 and this is equals to xy. Now, if you are going to multiply it, it becomes 8x minus 4, 8x minus 4y and this into this plus this into this. Now, 2x minus plus 2y, this is equals to 4x and 4y. So, equate the terms on the both sides. We are saying that this is the equality, means component wise the elements are equal. This implies 8x minus 4y is equals to 4x and 2x plus 2y is equals to 4y. So, put the terms on this side, 8x minus 4y minus 4x is equals to 0 and 2x plus 2y minus 4y is equals to 0. From these two equations, this is 4x minus 4y is equals to 0 and from here this is 2x minus 2y is equals to 0. So, from these two equations you can find that x is equals to y. Okay. So, when x is equals to y, if you are putting x is equals to k, so y is also equals to k. So, in this case your x eigenvector is, take k outside, this is 1 and 1. So, this is the eigenvector when your lambda is equals to 4. So, what would be your eigenvector when lambda is equals to 6 for the second case? So, based on the same pattern, there you will say Ax is equals to lambda x, this into this, instead of 4 it will become 6 now. So, same 8 into x minus 4 into y, for the second row 2 into x plus 2 into y, this is equals to 6x, 6y. Now, it will take the form as instead of 4, now it will become 6. So, when you will take this side, so this is, and here it is 8 minus 6 is 2, 2x minus 4y is equals to 0 and here it is 2x minus 4y is equals to 0. So, this implies x is equals to 2y. So, if y is equals to 1, so x is equals to 2. So, in this case your eigenvector is equals to, if it is k, so it is 1 and 2. So, these are the corresponding eigenvectors corresponding to eigenvalues 4 and 6 and its characteristic equation is given by this equation. So, in this way you can make so many characteristic equations with different equations. Now, let us study what do you mean by Cayley-Hamilton theorem. Cayley-Hamilton theorem says that every square matrix satisfies its own characteristic equation. Means to say that suppose A is a square matrix and P lambda is the characteristic equation generated by the matrix, square matrix A. Then it says that if A is a square matrix and this is the characteristic equation, then instead of lambda, if you are going to put A itself, the same matrix, the result will be 0. Satisfies its own equation means that when you are going to put the value there, the answer should be equals to 0, means that it satisfies that equation. Left hand side will be equals to right hand side. Now, this is what do you mean by Cayley-Hamilton theorem. Let us try to prove with the help of this example. Suppose A is equals to 1, 2, 2, minus 1. So, suppose this is your matrix and it is a square matrix. So, what we will do, first we will find the characteristic equation of this matrix. So, what is the characteristic equation of this matrix? A minus lambda into I should be equals to 0. So, we want to calculate this thing. So, what is A? A is your 1, 2, 2, minus 1 minus lambda into 1, 0, 0, 1. Because it is a 2 cross 2 matrices, so identity will be a 2 cross 2 matrices. So, in this case, what we get is 1 minus lambda. I am making one direct step. So, 2 minus 0, 2 minus 0. This is 2 minus 0. So, this is 2 and minus 1 minus lambda. This is equals to 0. So, if you are going to solve this determinant, this comes out to be, so this into this minus this into this. So, this is 1 minus lambda into minus 1 minus lambda and minus 4 is equals to 0. You can take a minus outside. So, when minus is multiplied by this becomes lambda minus 1 and this is 1 plus lambda minus 4 is equals to 0. So, this outcome comes out to be lambda square minus 5 is equals to 0. You make the calculation, it comes this. So, what now here we are going to make use of Cayley-Hamilton theorem. Because A is a square matrix, this is the characteristic polynomial of A, then Cayley-Hamilton theorem says that if you are going to put, instead of lambda square, you are going to put A square here, you will find that the left hand side is equals to right hand side. That is, it says that A square minus 5 is equals to 0. Let us see how. Let us first find A square. A square means 1, 2, 2 minus 1 into 1, 2, 2 minus 1. So, this into this is 1 plus this into this 4. This into this 2 plus this into this is minus 2. This into this 2 plus this into this minus 2. This into this 4 and plus this. So, 5. So, 4 plus 1. Okay, so let us look at the calculation part. This into this is 1 plus this into this is 4, this into this 2, this into this minus 2, this into this 2 and this into this minus 2, 2 into 2 4 plus this into this. So, minus minus becomes positive. So, this plus this is 0. So, this is 5. So, A square is your 5. Now, writing this equation is equivalent to saying A square minus 5 into I is equals to 0. So, now put this value of A square here. So, what we get is 5, 0, 0, 5 minus 5 into identity matrix. So, 1, 0, 0, 1. This is equals to, if you are going to solve it, this minus this. So, first term is 5 minus 5, second is 0, 0. This is 5 minus 5, which is nothing but your 0 matrix. So, this shows that the square matrix A, it satisfies its characteristic polynomial. So, hence we have shown that how Cayley-Hamilton theorem is applicable here. Key points discussed in this video are solution of equation using matrices, solution of equation using determinants, characteristic equation, eigenvalues, eigenvectors and Cayley-Hamilton theorem. Cayley-Hamilton theorem helps in expressing the inverse as a polynomial expression of a matrix. It is a very basic for commutative algebra, algebraic geometry and number theory.